Hi guys, I know that all of you are busy at home, so I'm going to kind of try to keep this as brief as I can. But I am asking you to fill out these notes completely for full credit for your homework. You can also go back and review things, back it up if you need to have it repeated. And so hopefully you'll think this is a good thing. At the end of this, I'd like you to leave a comment if you can, so that I can determine whether it's something that you really liked or if it really wasn't helpful at all to you. Tomorrow we're going to be practicing this, so it's important that you really go through these notes carefully. Okay, so let's get started. Actually, before I start, I just want to give you a couple of reminders that next week, the week of the 25th, is the last week that I will let you retake Unit 5. It's also the last time I'll let you retake any quizzes from Unit 5. Also, if anyone is willing to bring in AAA batteries for the calculators, that would be very helpful, as we are very short on them here at South Lakes. And so if you can help out with that, that would be great. Okay, now let's get started. Okay, today we're going to be talking about polynomial division. We're going to use two different methods to do that. There's long division, and then there is synthetic division. We're going to start with long division. And if you recall, when you used to divide when you were a kid, when you were a much younger kid, you would do that by taking the dividend. Taking the dividend, in this case, which is 509, putting it in the house, so to speak, and putting the divisor, the number you're dividing into that number, out in front. And then you would say, all right, how many times does 50 go into 12? Or you say 50 divided by 12, and it's 4 with change, right? So it's going to go 4 times. 4 times 12 is going to be 48. Subtract that, you get 2. And you're going to bring down the 9. Remember this? And then you're going to say, all right, how many times does 12 go into 29? And it goes twice. So 2 times 12 is going to be 24. Subtract and you get 5. Now 5 is our remainder. And when you were really little, you did r remainder 5, right? But then as you get older, you took your remainder and put it as the numerator, the top of the fraction, and then put it over your divisor, which in this case is 12. Okay, we're going to use the exact same method to use long division in polynomials. I did give you all the steps here on the left. Okay, so if you ever get lost, you can go back and reread them. Okay, but it's the same exact idea. There is one glitch to this. You need this, the polynomial needs to be in standard form. With all of the exponents accounted for. In other words, it has an x, it goes 2, 1, and then 0, right? This would be a 1, and then there's no exponent on the 5. Okay? And so all of them need to be accounted for, just like when we did synthetic substitution. If it's not, you're going to put a placeholder there, and I'll show you an example of that later. Okay, so we're going to divide our leading coefficient into, leading term into the leading term. So in this case, we're going to do, it's over here, 3x squared, right here, 3x squared divided by x. So that goes 3x times. Okay, and so we get 3x here. And it goes just right above the leading term that we're dividing into. And then 3 times 3x, 3x times x is going to be 3x squared. Plus 3 times 2 is going to be 6x. All right, now we're going to subtract. What I would suggest that you do with this is go ahead and put parentheses around this and change these. Make that addition here, subtraction, and so you don't get the signs wrong when you do this. Now this one was very easy. 8 minus 6 is going to be 2x. Notice these two terms cancel each other out. And then just like before when you brought down stuff, for this you're going to bring down the rest of the polynomial. In this case, it's just the minus 5. And then you go back to the beginning. You say, all right, how many times does x go into 2x? Easy one. It goes in 2 times, a positive 2. So we get 2 times x is going to be 2x. And then we have to remember to multiply our 2 with this 2. And you get plus 4. Now again, I would suggest that when you're subtracting that you go ahead and change this to addition and then change the signs of these. That becomes a lot easier. These cancel and then you have a negative 5 and a negative 4 gives you a negative 9. Now you take that negative 9 and you put it back up here, so it's going to be minus 9 over your divisor, which is x plus 2. And so your answer is going to be 3x plus 2 minus 9 over x plus 2. Got it? Okay. Again, the steps are there if you need to do them. All right, let's move on. All right, I'm going to do 2 examples for you, and then I want you to do the other 2 on your own. Okay, so I'm going to start with number 3. Notice, is this in standard form? Yes, this is in standard form. Okay, and do I have all of the exponents accounted for? I have 2, 1, 0, so they're all accounted for. So I can go ahead and set this up. So I get x minus 1, divide it into 3x squared minus x plus 4. Okay? All right. So how many times does x go into 3x squared? It goes 3x times. So I'm going to put the 3x right above the number I'm dividing into. And I get 3 times x, or 3x times x, sorry, is 3x squared. And then minus 3 times 3x times the 1, or negative 1, is going to be minus 3x. We are going to subtract here. So again, I would, if I were you, go through and change this to addition and change the sign of everything that's here. That way you don't have to worry about missing a sign along the way. These cancel, and you get negative x plus a positive 3x gives me a positive 2x. And then I bring down the rest of the polynomial. Okay, now I'm going to say, how many times does x go into 2x? Okay, so it's 2x divided by x, and you just get 2 for this one. Okay, so you do less 2. 2 times x is 2x. Positive 2 times negative 1 is negative 2. Subtract. Once again, I'm going to go through, because I like to do it that way. Make that addition, subtraction, addition. Then I can just add these. So I get these cancel, and you get 4 plus 2 is 6. 6 is my remainder, and it's positive, so it's going to be plus 6 over x minus 1. And so my answer is going to be 3x plus 2 plus 6 over x minus 1. Okay, and I'm going to do one more example for you, and then I'd like you to pause it after I finish this for you to try a couple of these on your own. I'm going to do number 4 now. I chose 4 because it doesn't have all of the exponents accounted for. This is in standard form, but it's missing a couple of exponents. It has a 4, it has a 3, but where is the 2? The 2 exponent. Okay, so we need to write that in. So you get 5x to the 4th plus 14x to the 3rd plus 0x squared plus 9x. Now one of my students asked me, why 0? And the reason I choose 0 instead of 1 is because 0 makes that not worth anything. Okay, and so now we've got it in the correct form. So I can rewrite this, set it up. I get x squared, whoops, okay, x squared, okay, plus 3x divided into 5x to the fourth plus 14x third to the third plus 0x squared plus 9x. Okay, so I'm going to say to myself, all right, how many times does x squared go into 5x to the fourth? Well, I know it goes 5. The 5 has to be there, and then I need 2 more x's, so 5x squared. If you want to do this off the side, you can. Oops. Darn, sorry. All right. So when I multiply this out, I get 5 times 1 is 5, and then x squared times x squared is going to be x to the fourth. And then I don't forget I need to multiply my 3x as well. So 5 times 3 is 15, and it's positive. X to the second times x to the first is going to give me x to the third. I'm going to subtract this, and again, I'm going to do like I've done before. Change this to addition, and then change the sign of everything behind it. Which is nice, because these will cancel. And then this ends up giving me negative 1x to the third. I'm going to bring down the rest of my polynomial. So plus 0x squared plus 9x. Okay. Now I'm going to say, go back to my lead term. I'm going to say, how many times does x squared go into x to the third? Well, I need the negative 1 to be there, right? And I need one more x term. So there it is. So I get negative 1 times 1 is going to be negative 1 x to the third. And then negative 1 times 3 is going to be minus 3x squared. And I'm going to subtract that. So just like before, I'm going to change that to addition and change the sign of everything behind it. So when I add these cancel, and I get 0 plus a positive 3 gives me 3x squared. Be very, very careful with the signs on this, because that can really mess you up. And then I bring down that last term, and I say, all right, how many times does x squared go into 3x squared? It will go evenly evenly 3 times. So 3 times x squared is going to be 3x squared plus 3 times 3x is 9x. And this one happens to go in evenly. And so there is no remainder. So my answer for this one is going to be this right here, this 5x squared minus 1x or minus x plus 3. Okay, go ahead and pause your video right now and finish these last 2 problems for me, and then begin it when you're ready to start up again. All right, so hopefully all of you finished those other 2 problems, and I will, at the end of this, I'll give you the answers to all of the examples. But we're going to move on to synthetic division. And remember, synthetic substitution was much easier. This is also much easier, but there's a little catch on this one. This only works when your divisor, the number that's out in front, is a letter minus or plus something else. So something like x plus 2 or x minus 4. So this first term here has to be 1. Okay, it only works with that. Okay, and it's very similar to the way that we did synthetic substitution, except for that we do a couple of things differently. The first thing you do is you need to figure out what the number is going to be out in front of the number that you're going to be multiplying every time. And the way you do that is you take your divisor, this x minus 2, you set it equal to 0, and you solve. So x is 2. So that's going to be my number that comes from the divisor. Okay? And the way you do this is, just like you did when you were doing synthetic substitution, you're going to drop your 1 straight down. Okay, then you're gonna multiply these two together. Okay, you're gonna multiply. So 2 times 1 gives you 2. So you get your 2 goes here. And then you're going to add these together. So and then you do 0 plus 2 is 2, and you go back the way we just did it. So 2 times 2 is 4. Add these together. And you get -3. 2 times -3 is -6. Add these two together, and you get -10. Those bottom numbers are going to be your new coefficients. So the answer to this one, and you always start with one less on your degree. So if this one was degree 3, we're going to start with x squared. So in this case, it becomes 1x squared plus 2x minus 3, using these coefficients, minus 10 over our divisor. Remember, the divisor was this x minus 2. And so this ends up being our answer. A little easier than what we just did. Okay. Let's try another one. I'll do a couple of these too. Let's do number 2 first. Again, we need to make sure that this is in standard form and that each of the exponents is accounted for. So it is in standard form, but we don't have an x to the first power. I'm going to rewrite this. 2x to the third plus 3x squared plus 0x minus 1. Now I've accounted for all of the exponents. This 3, 2, and then this would be our 1, and then the 0. Okay. The second thing we need to do is to figure out what the number is. It's going to be out in front here. Oops. Okay. All right. So I'm going to go ahead and write these first. So 2, 3, 0, and -1 are my 4 coefficients. And then I'm going to take this x minus 4 and set it equal to 0. Or x plus 4, sorry, and set it equal to 0 and solve. Notice, it's just the opposite of what it is. So it's positive 4, it's going to be a -4 out here. Okay, so you bring the 2 down. 2 times 4 is -8. Add those together. Okay, I'm bringing that here. Add those together, you get -5. -4 times -5 is positive 20. Add those together, and I get 20. And -4 times 20 is -80. Add those together, and I get -81. Not a very nice number, is it? Hopefully I didn't make a mistake anywhere there. Checking my work real quick. Okay, and then I just rewrite it with my new coefficients. So in this case, I'm going to come down here with that. I get 2x squared minus 5x plus 20 minus 81 over my divisor, x plus 4. And that's my answer. Okay? So what I'd like you to do is pause this now, and I'd like you to try the rest of these problems, and then tomorrow we'll work on them in class. And when you get done working all the problems, then click back on, and I'm going to give you all the answers. I'm going to write them all in. So take a moment to do that. Okay, guys. Here are the answers to these problems. For number 2, you should have gotten 3x squared plus 4x plus 5. Okay. And scrolling down here. This problem was actually the example for the synthetic division. And so the answer for that one, was x squared plus 2x minus 3 minus 10 over x minus 2. Same answer as we got for the example. Good thing. Okay. For these problems, for number 3, you would have gotten, let's see, where did it go? Oops, I'm sorry. For number 3, excuse me, you should have gotten 3x to the third minus 2x squared plus 4x minus 5. And that one actually goes in evenly, so no remainder of that. Okay. Number 4, you should have gotten 1x squared, or just x squared, plus 3x minus 1 minus 27 over x minus 3. And the last example, you should have gotten x squared minus 5x plus 3. All right, you guys, I'm looking forward to your comments. I was trying to keep it under 20 minutes. I'm just 1 minute over. So I'm looking forward to seeing how this works out. I will see you tomorrow in class. Thank you.